Okay, last bit. Now I'm actually looking for the minimum. Okay, what's the quickest time? Right? So in order to get that, I've already got an expression for the total time taken, capital T. And what I can vary, the thing I have control over, is where I land. What x is, right? So therefore, what derivative am I after? dt on dx. That's what I want, okay? That's a little bit messy, but it's not impossible, okay? You've got your, you're going to have chain rule coming out here. It looks to me like I'm going to have half 9 plus x squared to the minus a half times 2x. There's the derivative on the inside, and that's just the numerator, so I'm dividing everything by 2. You okay with that? Is that okay? So far so good? Yeah? Okay?
Yeah. So
Yes?
why do you keep the divided by 2?
Because if I'm differentiating this, I'll differentiate the top, which gives me 1, but then I'm dividing the whole thing by 2. The derivative of this is a half, it's not 1. Right?
You can rewrite it as half x and then...
Yeah. So it's, if I'm differentiating this whole thing, I can't just take the 2 away. Just like the derivative of this is different to the derivative of this. It's just a constant, just a constant coefficient. So I've taken care of this guy with some simplifying to be done. And then my other one is here, right? Now that 10 over 5 is just 2. He differentiates away. What am I left with? This will become minus 1, negative 1 over 5. Okay, let's just tidy this thing up. Cancel, cancel. This should be on the denominator, right? So it looks like I'm getting x on 2 root 9 plus x squared. Take away a fifth. Happy with that? Is that what my derivative looks like? Okay. Now, what was the point of differentiating? Good. I want to find the minimum, which is where turning points will be. I need to find where the turning points are. So I will say possible turning points at where this derivative is 0. That's what I'm going to solve for. Okay. So you go ahead and solve. Now I'm going to save you a bit of time. When you put these together, right? So you've got x on 2 9 plus x squared equals a fifth. You okay with that, right? You're going to square stuff out. And where do we get to? Just to save a bit of time. Here we go. You're going to get to this point. Dot, dot, dot. I believe this is where you end up as you start to tidy. Are you okay with that? Right? But of course, we have two solutions for this, one of which is within the domain and one of which is not. Right? So at this point, I say x equals the square root of 12 on 7. I only take the positive case, and I state why. Because of my domain. Okay? I haven't answered the question yet, right? What I'm looking for is where do I get the minimum? And I have endpoints here, right? Hey, sir. Should I just give it to him?
Thank
you.
2 levels. Wow.
Yeah, it's like a whole stack of levels.
Wow.
Yeah, well, you know when the deputy comes to you, it's,
Yeah.
All right, now, therefore, what am I going to do with this, right? I'm going to be a bit silly, and I'm not going to worry about testing the nature of this stationary point. I don't need to. Can you see why? A couple of reasons. Number one, I'm gross. No, I don't want to differentiate this again. Okay. Secondly, because I have to test the endpoints anyway, right? The endpoints are 0 and 10, right? So when I do my table of values over here, okay. When I do my table of values, I'm testing for values of x, and I'm trying to determine, all right, what is the actual time I end up with? What's the actual time? Now, if I go 0, square root of 12 on 7, and 10. Remember, I've found this is the only stationary point in the domain. It can't do any other wiggling around. There's no possibility of any other minima existing. These are it, right? You've got this endpoint, and this stationary point. And those are your only choices, right? So if it ends up being a maximum, doesn't matter. I just ignore it and take an endpoint, right? I don't need to worry about that. Does that make sense? I do need some actual numbers here, okay? Now I have some actual numbers. You're going to have to pop these back into your function for t, which includes these two here, right? And I believe you get this, 3.37 ... and 5.22. Okay, I think you check if you get your same numbers with that. You do need to get numbers. You actually have to demonstrate that the endpoints are not going to be part of your actual minimum. Okay. Do you see, by the way, had I at this point spent like 5 minutes in here determining the nature of the stationary point, right, and finding, oh great, it's a minimum, which it is, right? At that point, I still have to test the endpoints anyway. I haven't saved myself any effort, right? So that is why I never go to the second derivative. I don't do a table of values for the first derivative. I don't need to. My actual values here in testing the endpoint are perfectly sufficient. Okay? So there you go. I have a minimum, right? There it is. Now just to save you a bit of time, because this will frequently happen, and you have a time here, right? So if you have all your decimal places there, I have 3.374772708. Okay? Once you do that, generally speaking, I mean, the question didn't ask you to, but it's a time, so I'd expect you to put it in hours and minutes. All you need to do is press the degrees, minutes, seconds button, and it'll convert it to this. 3, and we'll say that, and I think it says that, something like that. Okay? So this I read as 3 degrees, 22 minutes, and 29 seconds is exactly the same as 3 hours, 22 minutes, and 29 seconds. Right? So 29 seconds rounds down. So there's my answer, 3 hours and 22 minutes. Okay?